Phew. Hi everyone, welcome back to Learning Kotlin Live, and this is the episode 35. It's another chance for us to write more code. So basically, given an array of equal length strings, you'd like to know if it's possible to rearrange the order of the elements in such a way that each consecutive pair of strings differ by exactly one character. Okay, so that's a permutation, kind of permutation, but I think it it's most likely that it can be simplified to a combination, um, maybe even not a combination problem. So actually, it can be solved by brute force actually, but oh no, actually no, sorry. Actually yes, I guess. Can it be? So, is it possible that we will change like yeah, I think it's possible. If it's pure numbers, then we probably can't solve it. Can't solve it with brute force. I mean, if they can be, if there is only one letter, not quite, but so the ultimate simplified version of this one is if the list only contains an array of characters with only one character. So with this subset of problem, it's going to be it can be solved in brute force because actually that's a different problem. Sorry. So no. So the very naive solution would be permutation of permutation. You first, actually no, just permutation. You list all the permutations of this implementation of this list, and then you find one if you find from them and check if there's one available. But that's just too far away. But if so actually we can make a table of the list. That would be div table, and making this div table itself is n square, which sounds like it's not quite efficient. Yeah, the div table itself is it's actually n square. Sorry, it's n square. So with that div table, let's first take a look at the permutation method. There are and what's exclamation? How do I spell that exclamation? It's the factorial, yeah. The permutation of is it? No, it's combination, so it's actually like it's like this, right? Yeah, and x factorial of n, factorial k, and factorial of m minus n. So it's roughly equals to m. So that is just not going to it is just not too complex. That's a big order. But if we have a div table, and with that div table, like ABA and BBB is 2. Two, 0, 1. Don't care. 2. Don't care. Don't care. And that's A and B is 2. ABA and BAB is 3. And ABA and BBB is... how far is it? No, it's actually BBB and BAB is 1. So it's never possible. Dot bullet? Where does it even come from? Don't care, don't care, don't care. So this is the difference table of... let's be super explicit. Zeroth item, first item, second item, and this is the zeroth item, first item, second item. Yeah, that's the concept. So with this we have the table, and then all we need is to find a path. Let's start with we find anyone that exists in the first column, and then we try to find the next. We try to find a path that consists of only 1, and it starts with 0. Because there is at least 1, and we put it into a stack, and then we traverse it, and when the length is enough, then there's an answer. I mean, like, for instance, let's assume that there is 4 items. 1, 2, and probably 0. It said exactly 1, so no, it's not going to take 1, 0. So for this case, the path would be 0 to 3, and from 3, oh, we actually need one more column. That's weird. Okay, 0 to 3, and from 3 there can be anything to, it can either be 2 or 0. No, it can be 0, so that's a loop. So 2 to 3 to 2, and 2 to okay, I'm a little bit tired of this. Let's make it easier to read. That's a lot easier. 2 to, that's either 0 that's either 1 or 3, and we already have 3, so 3 to 2, 2 to 1, 1, 2 is 0, 1, path and 1 to 0. Nope. Let's assume that there is 1 path from 1 to 0. Then there is the loop. Actually, we don't care if there is 1 to 0, so. Because every item should be in the somewhere, so the items in the middle would need 2 left and right paths, but items on the boundary would only need 1, which is toward the middle. Is it a little bit too, I hope this is not too abstract to you guys. So for this table we can have a string array which actually would look like ABA. Let's start with AAA. And there are two differences between first and a second, zeros and a first. So let's call it ABB. And 3, so BBB. And AAB. So this is just something that fulfills this. We need to make sure this only follows. This only is correct. So ABB and BBB is 1 difference. That's great. And BBB and AAB is 2 difference. That's great too. So what about BBB and AAB? We need only 1 difference, so that does not fall. That does not apply. We need to change it for a little bit. How about AC and BBC? That's still not 1. BCB and ACB. That's 1 difference now. And 2 between for this and this. 2, yeah, that's 2. 1 between these 2. It's now actually 2. So let's make this B then. So that's BBB and ACB. That's 1 difference, 2 differences, 1 difference. How about this one and this one? 2 difference. So we This one and this one need to be 1 difference, and this one 2 difference. 1 difference, 2 difference, so the common one would be B. So 1 difference, 3 difference. That's just impossible because okay. So yeah, we can't have that. That's not possible. B. Actually, I probably have proposed a deadlock. That's useless. Maybe no. Oh, why not just run and it will give us some samples. That's actually a lot easier. Return false. So it would highlight all true test cases. Oh, that's a good one. So let's take this as an example. Then the matrix would be 0. Actually, let's don't care. 0. No. We care about the sequence, right? Should be true. Yeah. Well, it's not proven that we care about the sequence, but that's actually 3. BF1. No, that's 2. I'm sorry. ABC, BEF, ABC, BCC, ABC, BEC, 2. ABC, BBC, ABC, BDC. And that would be ABC, BF. No, BF, BCC. Wait. Okay. I'm always confused between the same and differences. Common and differences. I need to make sure. So 3 differences. 3 differences. 2 differences. 1 differences. 2 differences, yeah. BEF and BCC has 2 differences. BEF and BEC have 1 difference. BEF and BCC has 2 differences. BEF and BDC has 2 differences. BCC and BEC has 1 difference. BCC and BBC has 1 difference. BCC and BDC has 1 difference. BEC and BBC has one difference, and one difference between BEC and BDC, and that's one difference as well. So we can start with ABC. Then we can see that BBC is the only possible next one. Then we will see from BBC where's BBC? Here. Is it? Why? Oh, we need one more. And it's full of don't care. Yeah, that makes more sense now. So, the BBC, and this column shows BBC. There are so many options that we can take. ABC, BBC. We have already taken this one, so we can take either this one, or this one. So we will split it into 3 columns. That's actually ABC and third one, BCC, or BEC, or what's the next one? BDC. And then, so one difference, right? Yeah, BC. So then we can take a look at BCC. And that's the third item. So its difference is 3, 2, and 1, 1, 1. So again, it can be split into 3 items, but actually this one is used, right? No, not yet. This one is used. BBC is used, but BEC and BDC are not yet. So it's either BEC or BDC. And if we're using we're definitely not going to use a breadth first search. We're going to use a depth first search. So if we have picked BEC, that's the 4th item, and it is one difference between everything except the 0th item. So we can take either B, E, F, and then finally the fourth item, BC. No, it can't be there, so we can't. This is a incorrect selection, so we then pick BC 1, 2, 3, 4. Anything except, but there are only 2 items left. BF and what's with the other item that is not selected yet? BF, BCC selected, BEC selected, BDC not selected. So that's BCC. Then we look at BDC. There are 3 items that we can select, but none of it. But the only thing that is left, which is BC, which is selected. The only non-selected is BDC, BF actually, but BF is still incorrect, so no. I actually can't find one here, so we move on to this one. Well, we know picking ABC is definitely correct because it only has one next one, and that's the property of actually we scan these items and look at the numbers of properties. Like this one is 1. This one has 1 item that is only 1 difference away, and this one is there is how many items? 3, 3, 2, 1, 2, and that would be 3. So this one is only 1 item away, and these are too many. Three, 4, 4, 3. So actually it is promised that these two should be the tail and the head, but if they are like this, then it's easier. So yeah, there may be loops, so we need to brute force the candidates, and luckily with this we know that we can start with ABC and end with BEF. There's so many items in the middle. And what we were doing is by brute forcing, trying to find something that syncs the items that is in the middle. So with the help of the table, we can look up ABC, and we know the next one is definitely going to be BBC, like we have tried. Oh, actually, and then this becomes 0. This becomes 0. And the pointed BBC and BF is definitely linked to 0, 1, 2, 1. BF is definitely linked to 4th, which is BC. So BBC, where's BBC? Now counts to 3 and counts to 3. Anyway, actually, I mean, by deduction, I cross out the items that is still in the list. So it start with 0, 0, 3, 3. We started with 1, 1, 3, 4, 4, 3, and now that actually that start with just from one end. That makes things simpler. From one end, we start with ABC because we know it's definitely one of the candidates. Then we look at, so now it's crossed out. So every item that is linked to it is now, and because ABC, because this is 1, this was 1, so we're now connecting to BBC, which is the only possible neighbor. And now we recalculate, actually I mean for all ones that are here, we cross it out, we deduct. So this line is directly discarded. We can say it that way. And this line as well, because these are discarded, so wherever there's a 1, we deduct it. So here's a 1, and it is not available anymore, so now we deduct 4 into 3, and now we have what? The 4th item, BE, actually BBC. BBC, really? So it is this one that is deducted. It was 1, 2, 3, 4, but it is now only 1, 2, 3. So for the next one, we have 2 options. It is now actually 3 options. So we list them. We pick one of it. Oh, this is backtracking. I don't like backtracking. Can I avoid it? Can I avoid backtracking? 1, 1, 1. Right, we can't avoid backtracking, so so this one is picked. We need to pick any of the next one. Actually, sorry, because BBC is picked, so this one, no, this one, and this one is crossed out, and we don't care about this 4 anymore. Actually, it was already 4, 4, and later swap into 3. Well, we don't care about it, do we? It's 3 anyway. Before has 3 candidates, and those candidates are one is selected, first one is selected, and then number one is selected, then we cross out. No, we don't cross out at its face yet, so we find any neighboring items around it, and the only neighboring is BF, so we pick one, and then again, so the possible options neighboring BBC would be BDC or BEC or BCC. Then we cross out this one and this one. So now it was free, and now we only care about, we update all these crossouts. So here's 1, 1, but we don't update this row anymore. There is only 1, 1, and it was not affected. It is now 2. This is now 3, and this is now 2. So given that all of these options are all still larger than 2, we can't decide which one to truncate yet. So we need to backtrack. But we need to pick one for BDC. And we have picked BDC, that's here. So we're crossing this out and crossing this out. And we're updating these two. 1, this become 1 and this become 2. So there are too many 1s now. So this is definitely not an correct pick. So we backtrack and we discard BDC. So what about what if we picked BDC? What if we pick BEC? Then we cross out this one and this one. Then the affected would be, this would become 0, so this is more impossible. So it is probably BCC, and so we cross out the third item here, and 1, 2, 3, the third item here. The affected rows are these two, which become exactly all these three. So it becomes 2 and 1, and there's again too many 1. Really? There's no answer to this one? No, I don't believe so. So we only truncate when it becomes 0, right? But oh, we only truncate when there are more than 3 ones. So actually the first one is still possible. So actually this one is not possible, but maybe these two are still candidates. So let's start with BDC. And where's BDC? We pick BDC. This one is crossed out. And so the affected ones are, this becomes, no, it does not become 0. This become 1 and this become 2. And so BDC, with BDC we can, there are still, these two are still candidates. We don't pick candidates that are already 1 because we only pick 2s. So the next one would be here. That's BC. And this one is crossed out. And this one is crossed out. So it affects both of these. So this one is just not the answer. So we backtrack and we found that this one is just not a possible answer, and we already calculated this one. How about this one? BCC, and then we pick BCC. That's a third item. So the affected rows are these 3s. This become 2 and this become 1. We only picked 2, so the next one would be BC. And given we have picked BC, we're going to cross out this here and here. And the affected ones are it affects a lot. Both of these become 0. Really? 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 So there's no answer? I don't think so. BF. Oh, what? Here? BC? Yeah. So it affects this one, this one. It does affect this one. This becomes 0. Because it's not one difference away from. Well, never lower than 0, it of course never can. Oh, lower than 0. As long as it's positive? No. No, you can't pick. I'm too lazy, but basically that's the idea. I'm going to need to continue next time. I'm running out of time. See you again at episode 37. But yeah, all I wanted to say is the idea is to have a table, and we can look up the table and decide what's in the next one. And then we update the table by removing the items that is already used, and then we can find a solution. So that's all for today. Bye bye.